All right, so welcome. So this is going to be section 712, day one of our notes for Algebra 2. So hopefully, again, this video finds you well. Again, my apologies. Obviously, I stated in the first video I'll be out all day with that meeting. So again, we're going to be obviously doing page 39 of the toolkit. And then again, we'll be taking our quiz again, obviously, tomorrow with that logarithm properties. So again, just make sure you keep note of that. Again, equations of exponentials will be right after that on page 39. So just keep that in mind. So with that in mind, we'll just kind of jump right in to the notes. So what you have here in your packet, you have section 712, how can I graph it? So again, this is actually kind of one of our cooler activities that we do for chapter 7. I'm sorry that I'm not here to do it. Again, I would give you all the opportunity to do so. The problem is there's a lot of tools for this, and again, obviously sometimes might not know specifically how to use them. So again, I just wanted to kind of use them here, and then you can kind of just see and then just kind of give you the notes as needed. So make sure there's no guesswork or anything involved. So what you have here is actually, again, how can you graph it? We're going to be graphing the sine function. So obviously with sine, we talked about what it is in terms of using it as a trig function, being able to find it for a special right triangle, for example. But now we're going to actually talk about what is sine, just in terms of how we can actually put this on a unit circle. So as you can see, there's kind of this little box up here with this like pinwheel kind of deal, or I guess a full circle. So I have one actually right here with me. So as you can see, the wonderful Lego Eggo box. Again, no brand advertisement here. But again, as you can see, what I'm trying to do is I'm just going to go ahead and plot this in, or plot this in, I should say. So it kind of looks like this. Again, as you can see, this little box here, and I'll kind of switch my screen so it's a little bit easier to see. So as you can see, we have this little box here, and then what we have is we have this little pinwheel, and then what you would do is you take this little toothpick and then obviously put it through the center. And then what we're going to do is we're going to actually measure this. So as you can see, whoops, should put it up here. Whoops. So right there. So in this case, again, we would rotate it around. And then as you can see, what ends up happening is we have a line here on that you would measure the height. So what I'm doing is each time I go around, I'm just measuring the height of sine. So sine function, again, is actually the height of any of these situations. So this would be like a Ferris wheel. And what we're looking at here with that Ferris wheel is we're looking at, again, and how high does it go. So again, what we would have is we'd have this little itty bitty ruler. And as you can see, this ruler kind of can be lost very easily because it's clear. And again, you drop it, it's going to be hard to kind of get up. So what we're going to do is we're just going to kind of measure and go around these different parts as a rotation. So as you can see, Ferris wheel, if you've ever ridden one before, especially like amusement park or anything, again, Ferris wheel goes all the way around, full circle, and does a full 360. So again, what we're going to do is we're going to have the degrees of rotation for the platform. So this is like a platform. So think of this as like you're going up the platform, you're coming up, and then you're going to kind of go up and around, and then you're going to go down. So this is what we call the Ferris wheel down. Again, in the prompt for the story problem. So again, if you want to read that prompt in CPM, again, you can do so. So the first thing we're going to do, we're going to fill those in. So degree of rotation, obviously from 0 degrees, if we start there, again, it's going to be 0 degrees. It's not going to go anywhere. And then what we're going to do is we're going to end up rotating 15 degrees each way. So each one of these little tick marks is 15 degrees, as you can kind of see, hopefully maybe. So 15 right there. And what we're going to do is we're just going to go around the circle. So we're going to go 15, 30, then moving up 45, 60, and then again, we're going to go 75, 90, and then 105, 120, 135. So you got all those, and then 150, 165, 180. And then what you're going to notice, again, 195, 210, 225. Great. And then again, I'm getting down to my end here, so we'll just move it up. And then the last one's 240, 255, 270. There's a lot of them in here. 285, 300, 15, Then we got 330, 345, and last but not least, 360. Again, that 360 is the full rotation, so again, that would be like you coming all the way around the Ferris wheel and then coming back to where you started. So again, obviously you go up, you come down, and then you come back around. So with that in mind, well, what we're going to do is we're going to go ahead and measure the height of this, meaning, again, the measured height is what you're going to look at for that specific value. So the measured height, again, is what we're looking at from, again, how we measure it for the ruler. So again, I'm going to do my best here so you can kind of see this. Again, this would be us mimicking it here with the different Ferris wheels. So again, if we start, again, obviously we start right at that value. Again, we're going to start at 0. So what you should hopefully see right away is, again, since we're starting at the platform, again, what we're going to have is we're going to have a measured height of 0. So you can just go ahead and put 0. And then what we're going to do is we're going to go ahead and measure the 15 degrees. So again, what I'm going to do, I'm going to do my best. Again, my apologies. If it looks kind of crappy, again, totally understandable. Let's see if I can rotate this around. There we go. All right, and we get to 15 degrees. Now what you're going to notice is the line is right there. The line is right there at 15. And I'm going to go ahead and put my ruler down, flip it over. So the ruler, as you can see, can be measured. I know it's really hard to see here. Try to zoom in as much as I can. So the ruler, as you can see, goes by 0.1. So if we were to measure this, we would say probably around 0.1, 0.15 maybe. Again, I got the value roughly of about like 0.15, about 0.25, something like that there. So we're going to go about 0.25. And then what we would do is we would just keep rotating. So in this case, I go ahead and rotate this up to 30 degrees. And 30 degrees, again, if I measured it, I just keep going around. The 30 degrees I measure. This one's a little bit easier to read. As you can kind of see, it's a little bit more right dead set the center. And if you look, it's about 0.5. Again, if I'm measuring from that platform there from the top, so about 0.5. So I'm going to go ahead and put that there for that value. All right, so as you can see, what we're doing is we're just going to go around. So I'm just going to go ahead and keep doing it here. So in this case, we're just going to rotate it. And I'm going to go to 45 degrees. Actually, hold on. Let's see. We're at 15, 30. Oh, one too many. There's 45. Sorry, I was 1, 2 ahead. So now we're at 45 on that 45 degree angle. We're going to measure it. And as you can see, this one's a little bit more, roughly, and I got this one as about 0.7 or 0.70. Or 0.7, I should say, 70. All right, now we got that one. In this case, what we're going to do now is we're going to go ahead and measure to the value of 60. So I'm going to rotate again. Now I'm going to measure 60 all the way up on top, or close to top, I should say. So 60, I'm going to measure here. And I got for that one, again, getting kind of hard to see. Oops, I got to flip it over again. Getting kind of hard to see, but you're going to see that that value is getting really close. Really close to the value of about 0.85, maybe have somewhere between 0.9. Again, these are very crude estimates, so I'd go about 0.85 there. And then what you're going to notice is we're going to go ahead and go to 75. So I'm going to rotate another one, go to 75 degrees. We're almost getting to the top. I'm afraid of heights, so again, obviously this would not be my favorite spot to be on the Ferris wheel. But in this case, I move over and I measure it. Again, this is going to be really close to the value of 1, but not 1 entirely. It's going to be about 0.95, I'd say. And got that value. All right, and last but not least, we go all the way to the top. What you're going to notice is, right at the tippy top, we're going to end up being exactly 1. And this is, I believe, I don't know what the measurement is, but we would be ended up at 1 for that value. In this case, for 90. So in this case, the height. Now, what you end up noticing is here, we end up having all these values. And when we look at them, we're like, oh, this is interesting. Because, again, it follows a certain pattern. We go up by a certain amount each time. But now we hit that value 1. All of a sudden, we start rotating around, and we go the opposite way. So all of a sudden, now I get to that value, as you can see, at 105. So now I've crested at the top here. Crest again with that wave, and all of a sudden we start heading down. So in this case, again, if I measure this and I look really closely, what you're going to probably notice is you're going to end up having a value that's really close to, or in this case, exactly like the 75-degree angle. And what I would say, this is probably going to be about 0.95. And as we kind of go around, what you're going to notice is each one of these, as we continue to rotate around, we're going to keep going down, and we're going to have those same exact values that we did here when we hit that crest at the top of 90. So therefore, again, 0.95. So in this case, the next one, 0.85. And then the value 0.7 here. And then 0.5. And then 0.25, and then all of a sudden we get back down to 0. And as you can see, what ends up happening is here, once we get to 0, and as you can see, it's kind of hard to see because my thing's in the way, but in this case, we end up getting back to that value of 0. And if we think about that, it makes sense, because in this case now, we're at the same height that we got on the Ferris wheel from where we started, but now we're, again, across from it. So in this case, again, on the opposite side. So we go up, and then we came back down on the other side. So in this case, that value for 180 degrees of rotation is going to be 0. All right, so now we did all these values. Now we're going to be looking at this and like, okay, well, we got back down to 0. Now what? Well, if we're thinking of this as like, again, this is the ground. Now, if we're looking underneath here, again, obviously this box is cut. What this is we're going underneath the ground, and now we're heading for the Ferris wheel. So as you can see, this would be like the ride goes underneath, especially like if you're thinking like Disney World or something, like, again, those kind of roller coasters that go underneath the ground. Obviously, that's going to go under. So therefore, we're going to think negative. So as you can see, probably the pattern is going to continue. But in this case, what's going to end up happening is instead of having positive 0.25 now with that value, what's going to end up happening is we're going to have negative 0.25. And again, if I take this out and I look here at it, it makes sense, because in this case, if I continue to rotate, that value right there is the same height, but now in negative in the opposite direction as both the value for 165 and the value of 15 degrees. So now what I'm going to do is I'm actually going to go ahead and fill in those values for each of them as I kind of go around. So therefore, negative 0.25 and then 210 is just going to kind of continue on that beat of negative 0.5 there. 225 in this case again is going to be about negative 0.70. And then 240 is going to be the value of about negative 0.85. 255 is going to be the value of negative 0.95. And then the value, once we hit 270, now in this case, again, we rotate it around. 270 is going to be all the way around with that value. So, as you can see, again, we kind of hit that wall, but now where we're at is we're actually at the bottom of the Ferris wheel. So in this case, again, this would be like if a normal Ferris wheel, if you were, again, we're at the ground level, this would be, again, like at 0. But in this case, since we're going underground, this is actually at the lowest point here. So in this case, again, opposite of the value from the 90. So in this case, 270 is going to end up being that value of negative 1 there. And then, as you can see, once we hit that 270 mark, we start kind of going back up. And again, oops, if I'm rotating this way, sorry, things are starting to fall apart here. In this case, what you're going to end up seeing is we're going to end up rotating it back to where we began. So in this case, again, we got negative 0.95. We're going to, again, keep that same value, but now it's going to be negative 0.95 as we start heading back towards the surface. So in this case, 0.95. And then we got 300, which, again, will be the value of negative 0.85. We got the value of 315, so therefore that should be about negative 0.7 or 70. And then we got the value of 330, so therefore that should be about negative 0.5, I think, when I did it. And then 345, negative 0.25. And last but not least, we get that 0 degrees. And again, that 360 is, if you think about a circle, full rotation around, you officially completed the Ferris wheel, so therefore, again, you're back to where you started. All right, so now what you're going to notice here is, again, measured height. In this case, again, with the chart here, this is all the heights that were measured, in this case, again, with the values. Now, it says actual height above or below the platform. Again, what you need to notice is, again, if you're thinking about the platform here, all these values that are positive, these are the ones that are above. So in this case, I always tell myself, again, if you want to put them, again, I always put the little arrow here to remind myself. So all these angle rotations, no matter what, are always going to be positive here. And again, all of them are up because they're positive. And then once we get to that value, 180, once we hit that value of 180, what ends up happening is we go below. So again, just think of like you're going underneath the surface of that cave or whatever kind of deal with that Ferris wheel fun ride is. So therefore, arrow all the way down, and you can get those values. All right, so now what you're going to notice here is, again, our last thing. What it says all the way to the right, and I'm going to kind of transition my camera so you can see this a little bit better. In this case, what you're going to notice is you got the sine function there. So again, this is sine, and then it says theta. Remember theta, when we talked about it on Friday when I last saw you, was, again, that angle measure. So in this case, the angle measure for this sine function, in this case, is going to give us the value for whatever that angle rotation is. This is the exact value for sine that it would be. And again, since sine is talking about the height of different angles of rotation, so the y value, if you will, in this case, again, it's going to give you that same angle measure. So therefore, again, the actual value or approximate, when we do it, again, is going to be very close. So obviously 0 is going to stay 0. But in this case, what we're going to do is we're just going to kind of go around the entire thing. So therefore, 0.25 was actually not too bad with that crude value. It's about 0.259. 30.5, actually in this case again ends up being the same value. The value for 45 is about 0.7. The actual one is about 0.707 there. Again, this is approximate value because again it can't be exact. 60, we got about 0.85. That was about 0.866 when you plug that in your calculator. 75 is going to be about 0.966. And then again the value of 1 once you hit 90, because again that value is straight up and down. And then we just started descent. So therefore, again, therefore that rotation all the way back around is going to be that value of 0.966. And then we're just going to go on descend. So 0.866, 0.707, the value of 0.5. And then we're going to get the value of about 0.2559 again. And then we get the value of 0 because again we come back around to 180. Alright, and then once we get 180, again obviously as you can see we start going negative again, so therefore we're just going to have the negative values with them in reverse. So negative 0.259, 0.5, 0.70, or negative 0.07, I'm going to show these as negatives, negative 0.866, and then negative 0.966, and then the value of negative 1. So again, we reach that bottom part, again with the Ferris wheel, we're the furthest below ground, or opposite of the value of 90 degrees, again where we were all the way above, and then we're just going to come back up to the surface. So therefore 285 is going to give us the value of negative 0.966, and then negative 0.866 with 300, negative 0.707 there, with that value for the, with each of. All right, and then again we got negative 0.707, and then we got negative 0.5, negative 0.25, 9, and then the value of 0 once we get back to 360. So in this case, again, we filled out this entire chart. So this is the actual values for sine now. So again, we've obviously talked about what sine is when we're talking about ratios for right triangles, opposite over hypotenuse. But now in this case, again, we have some actually assigned values for angles of rotation. The reason why this is going to be so important is because what we're going to do now is we're going to go ahead and graph what the actual sine function looks like. So in this case, again, 712, again, hopefully you got a chance to get this passed out to you by the teacher. If you have not done so, please ask her for one right now. Again, this did not come into your packet. The reason why is because it double printed with the extra homework. So again, as you probably noticed, in this case, you had 2 of the same homework assignments. That's my apologies. Again, it should have came out with this one. So again, if you just want to staple it in there or just keep it in your notes, again, whatever is up to you is totally fine with me. So in this case, what we're going to go ahead and do now is we're going to go ahead and graph this. So what I want you to take a notice of, obviously in this case, what the x-axis is. As you can see, the x-axis goes 30, 60, 90, 20, 120, 150, right? It's going up by those values of either, in this case, 15 each time or opposite of 30. What this is the actual x value, or what we call the angle of rotation. So the angle of rotation, again, is just the values that go around. So again, this is what we're going to use as the unit circle kind of coming up here the next couple of weeks, and we'll talk about that. So the angle of rotation, think of that as, again, like the Ferris wheel. So therefore the angle of rotation, and then again, as you can see, these are the height. So again, this is the actual what sine is. So in this case, the height function for sine. So just keep that in mind when you label those values. So what we're going to do, we're going to go ahead and graph these. Again, if you got a different colored pencil or something else, please use that. I only have an orange pen. The reason why I'm using orange is so you can see it better. Sometimes these videos, obviously, if you remember, are not easy to see. Again, I'm just glad the audio is working with them as well. So what we're going to do, we're going to go ahead and graph them. So again, hopefully you had the chance to fill out the data table. So we're just going to go ahead and go around the rotation. So again, this is the data table that we filled out just previously a couple of minutes ago. And we're going to go ahead and do the rotation. So I'm going to start at 0. Obviously, when we started at 0, we had a height of 0. So I'm just going to go ahead and put a major dot there. Then what I'm going to do is I'm going to go ahead and go around. So in this case, I'm going to start at 15. But now I'm going to go ahead and graph that value for sine of that angle rotation for the Ferris wheel. So in this case, again, it was 15 degrees, and that height was about 0.259. So again, just using your best estimate there, that value of 15 would look something along those lines right there, right? So we got that value. Then I'm going to go ahead and keep on going. 30 was that value of 0.5. So in this case, again, that 0.5, that's that value there. All right, we go to 45. 45, if you recall, again, was that value of about 0.707, so I'm just going to be just above 0.7, right there. 60 degrees, that was the value of about 0.866, so I'm going to go to 60 and go up to 0.866 here. 1 over, my apologies. All right, and then we're kind of getting close to the top. We're going to go to 75. 75 is halfway in between. That's going to be the value of about 0.966, so get really close to the top there. And then we get to 90, and again, we top out. So in this case, again, that's our highest point of the actual function there for sine. So as you can see, it's kind of almost looking like a little bit of a parabola, right? In this case, again, we start up, and we start to, obviously, so now we're going to start to come back down. So in this case, with that angle of rotation at 105, I'm going to go ahead and just plot the same kind of value. So in this case, again, it's going to be 0.966. So I'm going to kind of measure it out there. The value of 120, again, with that angle of rotation, is going to be about 0.866 there. Again, about equal with the value of, in this case, 0.866, about the value of 60 degrees there. All right, we're going to keep going. So in this case, 135. And we're going to get the value of about 707. Sorry, ignore that point there. Almost made that mistake. Just put an X through that. And then again, we're going to keep on rolling. So in this case, we're going to be at 150 degrees. 150 again, we're kind of descending down. We're going to be about 0.5 there. And then we get to 165. We're going to be at about 0.25. And last but not least, we get to 180, and we're back at 0. And again, this is like on the opposite side of the Ferris wheel. And as you can see, this looks very much like a parabola that we've done in the past. But again, this is not the same thing as a quadratic. So don't even put those two together. Again, they have the same similar shape, but as you can see, again, this is going to be something a little bit different. All right, so now what we're going to do is we're going to go ahead and graph the second part of the sine function, which in this case, again, would be the underground version of the Ferris wheel. So therefore, the underground version, again, 195, that's going to be the next rotation. We're going to go down, but now we're going to be in the negatives. So therefore, again, we're going to have about negative 0.25 there. So I'm going to go ahead and graph that part. 210, again, that was about negative 0.5 there. So I'm going to go ahead and go down to negative 0.5. All right, and then I'm going to get to 225, and that was, again, 225 was about negative 707. I'm going to go ahead and put a dot there. 240, again, was the value of 0.866. I'm going to go down 0.866 there. All right, we're starting to get towards the bottom, and therefore, again, we're going to get to negative 255. Negative 255 is about negative 0.966. Getting down there at the bottom. And last but not least, we get to 270. We finally get to the bottom. All right, so this would again be like at the bottom of the Ferris wheel, opposite of the actual height there. So again, we got the tall part. Now we're kind of coming back around. All right, so now we're going to finish it up. We're going to go back. In this case, again, this is 285. We're going to be at 0.966 again, or negative 0.966, I should say. 300, we're going to be at 0.866 here. Negative again. 315, we're going to be at the value of, in this case, negative 0.707, I think, again. It's going to go right here. We're going to be at 330. That value is going to be negative 0.5. All right, almost done. We get to 345, negative 0.259, about 256. Get to that value there. And last but not least, we get to 360, and we're back to where we started again. All right, so now, folks, as you can see, this is your sine function. So this sine function, again, looks very similar to a lot of the shapes that we've talked about in the past. But what you're going to notice here is, again, we actually made, again, this thing called a cyclic function. So a cyclic function or sine function is a cycle. So if you think about, again, if you ride your bike, right, and you complete one cycle of the tire rotation, or a car, for example, right, one tire rotation. This is the same kind of idea. So we start up, we go down, and then we come back to where we started again, and then we complete the cycle again. So again, obviously, as you can see with the sine function, it's going to have its max height of 1 no matter what. So in this case, again, that value is never going to change away from that. In this case, again, what we're going to call this eventually is the midline. And then the bottom part here, in this case, again, is the lowest value, or in this case, the minimum. Again, we call these, again, obviously, if you're looking at it from a science lens of view, again, you call this, like, obviously the crest and the trough of a wave. So again, you may have seen this when you study physics for sound waves, or different kind of things within chemistry as well. So again, all kind of related. But the big thing that you kind of take away from this, this is, again, using the analogy of a Ferris wheel. Start here, halfway across, you're still at 0, and then you come back around and start where you begin again. All right, so this is the sine function. Again, 712, how can you graph it? Hopefully you found this video very helpful. Again, it's going to be a little bit tricky with the homework. Again, just do your best with it. Again, hopefully you're able to kind of get these notes down. Again, it's going to be very beneficial, because eventually tomorrow, the next couple of days, we're going to talk about cosine and actually how you can graph that. And that's actually going to be the length. So in this case, the width kind of measure of the triangle on the unit circle. We'll talk about that. But otherwise, have a great rest of your day. Again, hopefully you get the chance to get the homework done. Please let me know if you have any questions, and hopefully you're good with the sub. But thank you for watching. Have a great rest of your day. Bye.